Hey everyone, time for question 3. So approximately 3.5% of all children are born from multiple births, so twins. Of the children who are from multiple births, 22 are left-handed. Of the children who are born from single births, 11% are left-handed. Okay, this is your probability question if you haven't noticed that. But this is a perfect time for a tree diagram. So the first thing that happens in life is you're born. In other words, the first branch of your tree is, are you a twin or are you a single child? And they give you the associated probabilities of that. The probabilities of being a twin is 3.5%. Now what that means is 0.035 as a decimal. And that means if you take 1 minus this, you'll get the remaining probability of being a single child, which is 96.5% or 0.965. The idea is every single kind of vertical, summing here within your branches should add up to 1. So whenever you break off your branches, add up all those branches, they should add to 1. All right? It's 100% guaranteed that if you're born, you are either a twin or more, or you are a single child. So there you go. So I guess I should say multiple, but we'll say multiple birth. Okay, now from there, it says we have left or right. Of the multiple births, 22% are left-handed, and that means of the remaining, you have to be 78% of multiple births would be right-handed. Again, every branch has to add up to 1. Similarly, left or right, if you were a single birth, that happened 11% of the time, which means the right-handers of single births would be, actually, let me make sure. Yeah, they gave me left-handed, they gave me left-handed. Sometimes they give you left-handed for one and right-handed for the other. Just be really careful when you read that. So this is 0.89. Okay, so what is the probability that a randomly selected child is born left-handed? Now what you need to realize is what that means is you need to follow both branches that take you to left-handed. So either you were a multiple birth child and then you were left-handed, or you were a single birth child and you were left-handed. Now, my use of or and when I said that is very actually particular to the problem. When you say and, that means multiply. When you say or, that means add. So either you were multiple birth and left, multiply those two, or you were single birth and, so then I multiplied. And let me calculate what that is just so I have it written down. Right. Oops. Put an extra plus sign in there. Okay. So probability is of, I guess I should say selecting a left-hand birth. Selecting left-handed individual in the region is 0.1139. Okay, part A, done. Hopefully I got it right. Part B, what is the probability that a randomly selected child in the region who is, that a randomly selected child is from a multiple birth given that they're left-handed? Okay, this is a conditional probability question. So multiple birth given that you're left-handed. The way you find conditional probability is you find the probability of the and, multiple birth and left-handed, divided by the given, which is probability of left-handed. Here's the big secret of this problem. You just found this answer in part 1. So all we have to do now is say, what's the probability of multiple birth and left-handed? Well, that's just these two multiplied. So that is 0.035 times 0.22 divided by being left-handed, which is 0.1139, and that is say approximately, since I'm rounding, 0.0676. All right, hopefully that's right. on to part C. So far I feel pretty confident about this one. A random sample of 20 children is born in the region will be selected. What is the probability that the sample will have at least 3 children who are left-handed? Okay, now I see the idea of this question, but it can be a little bit tricky. Now the idea is we can assume that there are more than 200 children in the region to sample. So a sample of 20 would have independence. That's not the best way of wording that, but essentially you can assume that because there's way more than 200 children in that particular region, most likely, then sampling 20 would be considered independent. Your first selection wouldn't really influence your other because there's so many people to sample from. That's really kind of what's going on there. Okay, now with that being said, what that means is you can assume this meets binomial criteria. All right, so again, what that means is 20 trials. We're going to select 20 students. Probability of being left-handed is independently 1139, since independent. There's only left or right handedness. So again, let's see here. The probability of success or failure doesn't change between trials. There's a fixed number of trials, and there's only left or right. Yeah. So these are the conditions for being able to use the binomial probability. Now, the way we can answer this is if we want 3 or more. 3 or more, that's what we want. That means we have to exclude 0, 1, or 2. And the idea is, if you think about this, if you know how binomial works, if I asked you to calculate 3, 4, 5, 6, 7, 8, 9, that would take forever. So we actually want to focus on how can we just find the answer we don't want that only contains 3 options, either no left-handed, 1 left-handed, or 2 left-handed. And then if we subtract that probability from 1, we'll have at least 3 are left-handed. All right, so because this is binomial, here's how I'm going to do that. I'm going to go to binomial CDF. In other words, I'm going to choose the one that will cumulatively find all this information for me. If you're going to go to the calculator and do some work here, you might want to say in calculator, I used binomial CDF, and you want to write down what you put in the calculator. Trial was 20, probability was 0.1139, and since it's CDF, you want to set the x value to 2. Now what that's going to do is it's going to calculate the value of being 2 or less. Now that's what we don't want. Okay, that's me putting all that into the calculator. It gives me this. So now what I'm going to do is I'm going to write the probability of 2 or less left is 0.5976 when we round it. So that means the probability of 3 or more, in other words, at least 3, so I should write that, at least 3 lefts in 20 will be 1 minus that, which is 0.4024. Okay, finally, all my answers. Now let's see how we did. Okay. So let me go to the scoring guideline. Oops, where'd it go? Here we go. Okay, so now again, I used a tree chart here in my problem, but eventually you can see I have the same answer. It's 0.035 times 22 plus 0.965 times 0.11. So awesome, I got that. Now I've rounded mine to 4 places. There usually is a place on the free response questions that tell you what to round to. I guess since it was only one more decimal place, I could have kept it. But let me see here. Does it say any notes on rounding? It doesn't. But when you get to your AP exam, they will give you more information on that, or we'll cover that more in depth later. Okay, up next from part A, again, we already had the bottom value. We just needed to multiply the top value, so there's our answer. And on the bottom, this is how you actually would have to go through the binomial problem yourself. Now notice what they're doing is they're not using CDF, they're calculating the odds of being 0, being 1, being 2, and subtracting that from 1. So they're technically using the same method as me, they're just doing it a lot more in depth. So rather than just running to the calculator, they're showing you that you can do the binomial exactly for 0, exactly for 1, exactly for 2, and then eliminate those options, and you'll then have 3 or more. Okay. So how do you get your E's, P's, and I's? For part A, you have to give the correct computation, and work is shown that includes correct values in the formula. End result from a tree diagram or some other appropriate strategy. So in other words, you have to show how you were getting your answers and why it makes sense that you're like multiplying and adding in the way you are. Now in this sense, a tree diagram is really the best way to go. It just felt natural to me to do it this way. But it turns out that tree diagram can be part of what gives you the E. Okay. Now if you give a tree diagram, but you have some inappropriate values, you make some mistakes along the way, that'll be a P. Or if you give the correct probability, but again, you don't show enough work to show how you did that, you don't get all the credit. Now, essentially, in probability, or really in statistics, they want to see the work. If you're going to put something in your calculator, show either, like down here, what you put into the calculator, or explicitly show the work that you did to get to your answer, like I did right here. So I didn't just say the probability is this and plug that into my calculator, I wrote it, and then wrote that down. Okay, part B, do you have the correct probability with work that includes appropriate values for the numerator and denominator? So again, notice that I'm just not jumping to my solution. I'm showing that I know that this is conditional probability. I looked at my reference sheet. Well, I had it memorized, but you can look at the reference sheet for conditional probability, and then I calculated each one individually before jumping to my final answer. So they want to see that. They want to see that you understand where the numerator comes from and the denominator comes from. Now, if you make one mistake in the numerator and denominator, you can still get credit, but if you make a mistake in both, you get an incorrect. Last but not least, for part C, did you base yours on the binomial distribution? Did you select appropriate values for n and p? So n is the 20, and p is the 0.1139 that I was using before in part A. Did you get the correct endpoint value for the probability? What does that mean? Uses correct direction to calculate the probability of at least 3. Oh, endpoint value for probability. So in other words, are you realizing that you need 3 or more? All right, so that's a very important indication. So some people might mistakenly read that as more than 3 and only start from 4 and above, but just be careful about that. And then again, do you correctly calculate binomial probability consistent with previous work? And what that means is whatever you put at the beginning, when I kind of went through that analysis, that's what they mean. If you get these incorrect, but technically do the correct method based on what you wrote incorrectly, you could get number 5 right, but that's definitely not going to get you all the way to an E. So in E, you have to do all of those things, and you also can get a partial if you got 1 correct, essentially that you found it was binomial, and maybe you chose N and P and indicated that you were finding 3 or more correctly, but yeah. Okay, there again are usually notes to get a little bit more specific, but